Okay, so now let's see how these transformations work. So remember, you have stretching, shrinking, you have reflections, you have translations. They're all transformations. So you can do more than one thing. So here's an example. We have a few examples. They want us to graph this. So one thing you can do, this is a good idea, is look at the pieces. What does that sign say? That opposite sign. Now this is an absolute value function. So a lot of times I would first say identify the function so you know what it looks like. Absolute value makes a V shape, right? So we're expecting some sort of V. The sign in front of the function, that means it's going to reflect about or with respect to the x-axis. Now, you might be saying, well, how do you know? How do you know when it's the x and when it's the y? It has to do with when you do the function. Do you do the function and then take the opposite? Or do you take the opposite and then do the function? So if it's this way, and this way is function, then opposite, then it's going to reflect with respect to the x-axis. Okay, this -3 is going to shift. It's going to shift our graph 3 left. Okay, that's a horizontal shift. Again, how do you know which one's horizontal and vertical? If you do the subtracting or adding before you take the function is the absolute value part. If you do your adding or subtracting before you do the absolute value, then it's a horizontal shift. And then this one out here is going to be a shift of 1 up. Okay, now you could just use the transformations to graph this, but I'm going to do a table of values for you in case you're like, I'm confused, I don't believe this. Okay, so let's do a table of values. I'll show you how to do this. And on the test, you might say, oh, this is going to be easier. Or you might want to do some combination of both. It's nice to identify this, and then when we get the table of values, if it looks right, we'll know. Okay. So the thing is the horizontal shift right there, 3 left. So I would put in, because it's going 3 left, 1, 2, 3, right? Correct, I should say. I would put in -3, and I would put it in the middle, because that's going to be where the vertex is. Now let's plug it in. Let's see what happens. You put in a -3. -3 plus 3 is 0. The absolute value of 0 is 0. Minus 0, 0, plus 1. You get a 1 out. Okay, I'm going to do this in a different, I'll go back to the green. There's the point that we want right there, -3, 1. That is going to be the vertex. The vertex is that bottom point for the absolute value. That's called the vertex. Okay, so yay. Now I would just pick 2 points to the left and 2 points to the right. And by that I mean I would pick -4 and -5. And then I would pick -2 and -1. And you might say, well, why aren't you just picking like -2, -1, 0, 1, 2? Because then you won't get the vertex in this case, and you won't see it as, you'll think it's a line, and it's not going to be right. So you got to know where that vertex is, okay? You have to know the shifting. All right. You can try it and you get a line, and then you could say, hey, this isn't a V. I must have done something wrong, and pick some more points. That would work. Okay. So let's see what happens. If I put in -5, I'll start there. -5 plus the 3, that's -2. Absolute value at 2, but opposite, -2 plus 1, -1. So -5, -1. Okay. And if I put in -4, I get -1 from here, absolute value 1, but opposite of that, so -1 plus 1, I'm getting 0. Now, if life is working right for me, and I do have the vertex at -3, 1, these points should line up on the other side. So what happens when I put in -2? -2 plus 3 is 1. Absolute value of 1 is 1. -1 plus 1 is 0. -2, 0, right there. And then if you put in -1, you get -1 plus 3 is 2. Absolute value is 2. -2 plus 1. And it did make a little V shape. You could pick more points if you wanted to. Did it do everything we said it would? It's a V, yeah. Did it reflect about the x-axis? It did, but then it shifted up, and it shifted left 3. Okay? So there you go. Do I have another one? Nope, that's the only one here.